Hi my dear students, welcome to IIT JEE NEET classes. This is Ashok, chemistry faculty. Today I am explaining 2026 JEE advanced chemistry questions, particularly organic chemistry questions I am going to explain in this video. The question is, considering lithium borohydride reduces an ester group to the corresponding alcohol and it does not reduce a carboxylic acid group, the correct statement about the major products P, Q, R and S is. If you see that reaction, they given some molecule, one side carboxylic acid group is there, another side ester group is there. So they given lithium borohydride and one side, another side borane, that is BH3 diborane molecule. So lithium borohydride is a good reducing agent, particularly for esters. It reduces esters into primary alcohols. Hydration compound is treated with lithium borohydride. This ester group is converted into primary alcohol. This ester group converted into primary alcohol. Further, it is undergo acidic medium. This OH group present on the carboxylic acid take out this proton. Protonation takes place. Then dehydration takes place here. Then immediately adjacent carbon OH group is moved towards this carbonyl group. So ring cyclization takes place. So the product P is formed like this. So that is 1, 2, 3, 4, 5, 6 membered ring with COO group linking present. But with a diborane molecule BH3, carboxylic acids only converted into alcohol, but ester does not affected by diborane molecule. Only carboxylic acid is converted to primary alcohol. So the BH3 molecule affected only COOH group, carboxylic acid group, converted to primary alcohol, does not affect ester group. So further, this lone pair present on the alcoholic group is moved towards a carbonyl group of adjacent ester. So cyclization takes place. So due to cyclization, the product Q is formed. Now P and Q are both are non-superimposable mirror images. P and Q. So both are non-superimposable. Okay na? Non-mirror images. Non-mirror images. These two are non-superimposable and non-mirror images. That's why these are what? Diastereomers. P and Q molecules both are diastereomers. Diastereomers. But not enantiomers, but not identical groups, because both are non-superimposable not mirror images. Non-superimposable and non-mirror images. In second example also, the compound is treated with lithium borohydride. It is particularly converted into esters into alcohol. It does not affect carboxylic acid group. So primary alcohol is formed. So further, it is treated with acidic medium. So the OH group present on the carbonyl group will take out this proton. So protonated carboxylic acid will form. So then immediately water molecule will be removed. Then this lone pairs present on the alcohol will move towards carbonyl group. So cyclization takes place. So cyclic ring compound R is formed. Similarly, this molecule is treated with diborane, that is BH3 molecule. BH3 molecule can affect only carboxylic acid. It does not touch to ester group, does not affect to ester group. Only carboxylic acid converted into primary alcohol with respect to BH3 molecule. Further, it undergo acidification. This lone pairs present on the ester will take out this proton. Then ETOH will be removed. Then this oxygen lone pairs present on the alcohol will move towards carbonyl group. Cyclization takes place. Cyclization takes place. That is, the product is formed. So the compound S is formed. This R and S molecules both are non-superimposable, non-mirror images. These two are non-superimposable superimposable and non-mirror images. Non-mirror images. That means these two are diastereomers. This R and S. Before P and Q are diastereomers. Now R and S are diastereomers. So the correct option is option C. P and Q are diastereomers and R and S are diastereomers formed as a major products. The next question is, in the following reaction sequence, Q, R and S, T are the major products. For example, sodium sulfate carboxylic acids they given. It is undergo Kolbe electrolysis, then followed by V2O5 500 degrees centigrade, form Q compound. Then it is treated with another compound that is a phthalic anhydride, gives compound R. Then this compound R treated with PC alpha, then followed by Lindlar's catalyst H2 palladium BaSO4 gives S. Then it is treated with hydrogen, this T. So if you see that reaction, first carboxylic acids, sodium sulfate carboxylic acids undergo Kolbe electrolysis. So here sodium sulfate butanoic acid undergo Kolbe electrolysis reaction. We know very well must and should be the starting compounds are required 2 moles. So here what happen, alkanes undergo free radical mechanism. Free radical mechanism. So free radicals are formed. 2 moles. So that what happen, alkanes are formed as major product in this. So that is hexane is formed in this Kolbe electrolysis of sodium sulfate butanoic acid. Sodium sulfate butanoic acid undergo Kolbe electrolysis. Must should be, we require starting compound 2 moles. So this is free radical mechanism. Based on the free radical mechanism, it gives alkanes and carbon dioxide and NaOH and all. So hexane is formed as one of the major product. This hexane further treated with V2O5 at 500 degrees centigrade undergoes cyclization. It gives benzene ring. It gives benzene ring. Further, this benzene ring is treated with phthalic anhydride. So ring opening takes place here. The carbonyl group. So benzene ring attached to this carbonyl group cycle. So benzene ring attached to this carbonyl group. Further, it is treated with PC alpha. This carboxylic acid is converted into carbonyl chloride. That is benzene. COCl is formed. Carbonyl chloride is formed. Further, it is treated with H2 palladium BaSO4. Lindlar's catalyst. In Lindlar's catalyst, what happened? Carbonyl chloride converted into acid halides converted into aldehydes. This is aldehyde group. It form aldehyde group. COCl is converted into CHO. Aldehyde group. Then this aldehyde group is treated with a hydrazine, that is N2H4. Ring cyclization takes place. So this compound treated with a hydrogen molecule, then dehydration takes place by heating. Okay, cyclization for products formed. So cyclization product is formed. Then this is benzene ring as it is. So the given options are, so here compound S, given that compound T, cyclization product. So the correct statements from this reaction is, yes, on warming with ammonical silver nitrate results common formation of silver mirror. Yes. So here free aldehyde group is there. This aldehyde group is treated with ammonical silver nitrate, that is Tollens reagent. Tollens reagent gives silver mirror. So option 1 is correct. Then Q on treatment with chlorine. So Q is benzene ring. Benzene ring on treatment with chlorine in presence of UV light, that is excess chlorine, that is hexachlorobenzene, BHC, benzene hexachloride. Benzene hexachloride is formed. This BHC is also called gamaxine. So B also correct. T is a heterocyclic compound. Yes, T is a heterocyclic compound. Heteroatoms are present, that is a nitrogen atom. Then R on acid catalase intermolecular cyclization followed by treatment with zinc and HCl gives 9,10 dihydroxyanthracene. So this compound in presence of H plus undergoes cyclization. This OH take out that proton and H2O molecule will be removed. Cyclization takes place. So because of the cyclization we can get the product like this. Then further it is treated with zinc amalgamation, Clemmensen reduction, ZnHg and HCl. What happened? The CO become CH2. The CO become CH2. But they given 9,10 dihydroxy. No, this is 9,10 dihydroanthracene. So this is wrong option. The correct option is A, B, C. The next question is the sum of total number of carbonyl groups present in the major product X and Y in the following reaction. In these following reactions, carboxylic acid groups are present. The carboxylic acid groups present at the first compound at 1,3 position, the second compound at 1,2 position. So in the first compound, by heating, decarboxylation takes place. So what happens? Normal ketone is formed. There is no cyclization takes place because both carboxylic acid groups are present at 1,3 position. Only decarboxylation takes place, so that this name 5-pentanone is formed. 5-pentanone is formed. But in this molecule, by heating, but in second molecule, the COOH groups are present at 1,2 position. So here dehydration takes place by heating. Decarboxylation does not take place. So dehydration takes place by heating. So cyclization product is formed. So total CO groups present in X and Y. That is, here the carbonyl groups are 3 groups. Here the carbonyl groups are 1 group. Here CO groups are 3. Total 1 plus 3 is equal to 4 carboxylic acid groups present in that product X and Y. So 4 carbonyl groups. Here 1 carbonyl group. Here 3 carbonyl groups present in the compound. So together total 4 carbonyl groups present in the product X and Y. The next question. Treatment of buta 1,3-diene with sodamide to equivalents followed by reaction with excess of trans 1-bromo 2-butene gives X as the major product. The maximum number of carbon atoms that are collinear, that is in a straight line in X. First of all, treatment of buta 1,3-diene, that is CH triple bond C, C triple bond CH. 1, 2, 3, 4. Okay, now it is treated with a sodamide, that is a strong base. So this amide take out this proton because acidic proton. These two are acidic protons. When we added that base, immediately take out that protons. So what happened here in this disodium buta 1,3-diene. So that is Na will come plus C triple bond C, C triple bond C minus Na plus is formed. Then further it is treated with 1-bromo 2-butene, that is CH3 CH double bond CH, CH2 Br. This Br minus will move. The negative charged carbon will attack this carbon, that is so here SN2 reaction takes place. We can get a transformed, that is CH3. Here trans compound is formed, that is C triple bond C, C triple bond C. Then this is bonded with the CH2, C double bond C, CH3, H and H. So further it is treated with one more bromide compound. that is CH3, CH double bond CH, CH2, Br. So here also this C minus will treated with this compound. So finally we can get CH2, CH2, C triple bond C, C triple bond C, CH2, C triple bond CH, H, CH3, then it is treated with compound double bond. Okay, trans compound is formed. Trans compound is formed. This is the final product. In this final product, this is linear. That is collinear. In straight line, it is present 1, 2, 3, 4, 5, 6. 6 carbon atoms is present in collinear. That is straight line. So the answer is 6.